The first screen is some vocabulary. My screen is different than yours. But we're going to have a little discussion before. So I want you guys to notice we're switching gears here. We're going to proportion. Now, first of all, I want you guys to raise your hand and share with just raise your hand and share with the class if you know what that means. You are blowing things way out of proportion. What does that actually mean? If somebody says that, if your parents say you're blowing things out of proportion, or you say that to your parents, what does that mean, Garrett? Exaggerates. Stretches the truth. All right. So you've heard that. So we've seen proportions in other situations besides math. But another thing is obviously the same. They do that we blow things out of proportion in many ways, situations. We also, cartoonists, use SpongeBob. Like this character, SpongeBob, they blew things out of proportion. So how do they blow SpongeBob out of proportion? What is that? What do you notice on his character? What's out of proportion with him, Nick?
His face is focused.
Compared to his legs. Okay. Obviously, we're proportional. Okay. And obviously, there's what else on here? I mean, they do this for a reason, right? Don't they make characters? They blow it out of proportion so they look funny. Have you ever had a character done where they make your head really huge and your body really small? They do that at Great America, or like you go on the streets of Hayward, Wisconsin. That's when my kids had theirs done. So if you notice, what else do you notice, Tommy?
There's like sleeves on his arms. No shirt there.
Okay. Well, I mean, you can see. I mean, like, look at the tie versus his body. His eyes compared to his head. I mean, it's like Bugsy on bedtime stories. Remember the?
Oh yeah.
Those eyes would look big on a cow. So here's Tweety Bird, one of my all-time favorite. Can you look at again? You can see the feet. You can see anything else? His eyes, his head, his hands. Look how small his hands are compared to the body and his head and his feet. So a little out of proportion. We do that all the time. Now.
Oh, there's eyes.
Okay, I'm sorry, but this is the stuff that freaks me out. Like those eyes freak me out. No, they have no nose. How do they smell? So obviously, Powder Puff Girls are out of proportion. So let's begin. First of all, we're on to proportions. Okay, and obviously knowing before you leave today, you should obviously know what a proportion is. Okay, how do we keep things proportional versus blowing it out of proportion? Okay, out of proportion means not equal ratios, or not the same. Okay, when we blow things out of proportion, it's not the same story as what really happened. Correct? So when we keep things proportional, we try to keep them the same. All right. So again, this word right here. That's not new, is it? No, you've heard of constant proportionality. Have you ever used cross products? I think you've probably at least seen it or done it before. Maybe not. I'm not for sure. Obviously, we're going to talk about how to set up a proportion today. And equivalent ratios, I believe that's not new as well, right? Equivalent ratios means what? Huh? Equivalent means what? Same. Common. Remember, that's the same. All of them are the same. All right? Equal. Same thing. All right. So now, did you guys solve proportions last year?
No, I don't know what proportions are.
Okay. So here's a good idea. So if I give you two random fractions and I say, are they equivalent? Are they the same? There is actually a process that you can do really quick in your head versus reducing and then comparing. What is called cross products. Like this. So if I give you any two random ratios, all you have to do is do cross products. Well, what operation is a product? Multiplication. So what I want you to do is you take cross. You take the numerator over here, denominator over here. What's 12 times 12? 144. And what's 36 times 4? 144. Is this equal?
Oh.
Yeah.
No way.
So are these.
That's so cool.
Oh my.
Oh my.
That would have been a lot easier, wouldn't it?
Yeah.
Yeah, it's a lot quicker than reducing it, right? Reducing both fractions into the same fraction. Now, you know other methods. I'm just showing you a quicker method, which we're going to use cross products to solve. Okay? So let's try this one. How about this one? 5 times 6 is 30.
Doesn't matter.
And 1 time, nope, it doesn't matter. Nope, it's an equation. Look at what it's set up. Listen, look, it's set up on an equal. If you flip it, it's still an equal sign, isn't it? It doesn't matter. It's not an inequality. Because if you flip an inequality, it changes, doesn't it? Okay. So we got 1 times 15 is? 15. Is this equal?
No.
No. Remember what you do is you do the little slash. So if they're not equal, if the cross products are not equal, which means those two ratios are not equivalent. Nick?
Can you, like, take the...
Are you writing these notes down, Noah, or are you just scratching on your binder? You should be writing these notes down so you have an example, because you're going to be practicing this on your, that's not your notes. Now you know where we're at? Next, sorry.
Can't you just, like, on the next one, 8 and 16, can't you just say 8 goes into 16 2 times?
Okay, we're practicing cross products for a reason, because that's how we excuse me, yes, but I want you to practice cross products. Why? Because that's the process that we're going to use to solve proportions. Okay, so that we're practicing this for a reason. It's not, hey, I'm just going to have you do this for the heck of it. No, there is a purpose.
Well, I knew that.
Okay, well, yeah. So 8 times 6 is
48.
48, and 16 times 3 is 48. So is that equal? Yes, it is, which means 8/3 and 16/6 are equivalent fractions.
If they were
Okay.
equivalent, do you want us to circle the problem, or do you want us just to leave it?
Leave it equal.
Oh,
Or not. I like this, leaving it equal or not equal.
okay.
Okay? Why is this not working now? There it goes. All right, so equal or not equal? So not equal would be not, I would just assume that if you put not equal between the two numbers, which means that the two ratios are not equivalent. Okay, because remember, these are not fractions, they're ratios. All right, we refer to, even though they're in fraction form, we're talking about ratios. First of all, can I ask you guys, what is a ratio again? Could someone remind us, what does the ratio do? Every time you set up a constant proportionality, what did the top and bottom do? What are we doing there? Ella?
Compares two things.
Two things. Two ratios that are equivalent are also called proportional. That's a proportion. If you have two or more ratios that are equal, that would be a proportion. All right? We use proportions all over math. We use it in geometry to solve for missing pieces or lengths on a similar triangle. We use, or on a polygon, a similar polygon. Any similar polygon you can use for proportions to solve. You can use those, if you have one unknown, you can actually use proportions in word problems if you know 3 other things. Okay? So I'm going to show you how that works. If you look at this setup here, this is what a proportion looks like. Do you guys agree we have 2 numerators and 2 denominators? Correct? Aren't there 4 places there? So if you have 1 unknown, 3 knowns, you can set up a proportion, and you can solve for that unknown by using cross products. And that's what we're going to try now. I'm going to show you how to do that without any meaning right now. We're just going to solve a proportion here. So we're going to do that same thing. We're going to use our cross products, right? So these are 2 ratios set equal, which means this is a proportion. 2 ratios set equal is a proportion, all right? So we're going to do our cross products. You're going to take k times 56, which becomes what new term?
56K.
56k. And right now we're solving for this right here. We don't know what that is, so we're solving for it. That has to be equal to 32 times 7. What's 32 times 7? Anyone? 200 and something.
224.
Mm-hmm. Now, have you ever seen an equation like this? Look what a proportion actually, the cross products turn into a equation. Have you ever solved this before?
Yeah.
What would you do to both sides?
Take away.
Divide by 56. So, divide by 56. And what is k equal?
Yeah, 4.
Try this one.
So it's just like kind of like
A proportion actually turns into an equation. A proportion means cross products are equal. You set the cross products equal and you solve for your missing variable. I want you to try this one. I'm going to go check on Mrs. Dupre to make sure she got her lunch. I'll be right back. Pardon me, honey?
Do we do the third one?
Just the third one. That's all I wanted you to do. Is that what you guys got so far?
That's what I got.
Yeah, I got that.
yeah, that's what I got.
How'd you get?
What?
How do you?
What?
You gotta times it less than 1. You gotta times it by a decimal. 8 equals less than a decimal. Less than 1.
Well, 8 goes into 11 how many times? Once.
1.
And that'd be 32, would be 4, right?
Oh, shoot.
Come on. Whoops.
Yeah.
Oh,
Does that
do you
be
keep the
1.40?
0 at the end?
No? Any questions on that? Now what we're going to do is we're going to use this process and we're going to solve some obviously word problems. Okay, so here, remember how I told you that sooner or later you're going to have to use write label over label first? Okay, so there's something that you're gonna first realize. What are the numbers describing? What are we comparing? We're comparing T-shirts to time in this particular problem. So Melvin can decorate 8 T-shirts in 3 hours. So you guys agree his rate is 8 to 3. All right. And then at this rate, write and solve a proportion to find the time it will take him to decorate 20. Well, what we're doing is, if we know one rate, we can set up a proportion to know, well, if 8 T-shirts are made in 3 hours, we can figure out how much 20 because we have one missing piece. Do you guys agree they're given 4 different things? Or 3 different things, excuse me, and we're trying to find the 4th. All right? So here, they did the first ratio where they have shirts over time. Do you guys agree that 8 and 20 are the 2 numbers within the problem that describe T-shirts?
Yeah.
Do you notice how they're directly across from each other? That is called direct variation, or it directly varies with the other variable or the other situation. When you have something, you guys, do you guys agree that y is directly across from x? Remember how I told you that this is direct variation? It directly varies. The 2 variables directly varies because they're directly across from each other. So when you do set up a proportion, your labels, shirts, the numbers that have to do with shirts are directly across from each other. They're the top. Okay? And then time, obviously, if 3 goes with 8, 3 has to go under 8. Does that make sense? That 8 and 3 are within the same ratio. Okay? It's one thing I'm going to tell you right now. A proportion is 4 different places. If you mess up one of the places, you don't get what you need. Okay? You're going to solve it wrong. So in T, you guys agree that the unknown is for 20 T-shirts. You guys agree that time is the unknown for 20. So that's why T is right underneath 20. So we have you cross multiply, and you solve. Whoa. Sorry.
Do you want us to do the lines still?
Huh?
The lines.
Like draw the
Oh, you can.
Do we have to though?
No, I don't. You can, though. Just make sure you get the right ones. So we got 8. What does T equal? How much time? Caleb?
It would make it like, is it 7.5?
Is it?
Yeah.
You guys agree?
That makes sense.
7.5 hours.
Because 8 times 8 equals 64.
It's 7.5 hours. Can you have a decimal?
Yeah.
Can you?
Yeah.
Sure. It's hours. You know what a half an hour looks like?
Yeah.
Or what it feels like to take a half an hour? Heck yeah, you know what it is. You can measure that. All right, let's start the next one here. So the first thing I want you to understand is you have to figure out what are the two labels. We need label over label. So what are we, find the first sentence and figure out what are we describing. What are we comparing? Anna? Money to eggs. So the first thing I should see on your paper, what the heck? So we got money to eggs, and this is how I set it up. So once I have that, I said that's equal to, so there's my proportion. I have one ratio here is equal to another ratio. Give me one ratio from the problem. Tell me. $1.12 for what? Over what? Nope. So you're paying $1.12 for 3 eggs. Thank you. 12 eggs. Okay. What's the other ratio? Why don't we just focus on the problem? Greta? So you're telling me you're trying to figure out, determine the cost, which means that's where our X is going to have to be, is where the cost is. And cost is where? On top. So the X is going to go on top, and we know that that's, we need to figure out the cost for 3 eggs. Now, do you have that set up correctly? Okay. Now, cross multiply. How much does it cost? So you got 12 times X, which is 12X, and $1.12 times 3 would be $3.36?
Yep. $
3.36. Because I just tripled the dollar and tripled 12 cents, and I got $3.36. All right, so we got $3.36. And then obviously, what operation are we going to use to solve for our cost? Division. And we got, how many times does 12 go into 3? 0. 12 goes into 33. How many times? How much?
2.
2?
3.
Well, you can't. You can't do 3. That's 36.
33. 21.
I wanted 33.
0 and 3.
Oh.
0.
Now we're doing 36.
You got 0.13.
Okay. So we got 12 goes into 33 how many times?
0 times.
2 times. We got 24. And then we got, what, 96.
How would you?
8. So how much for 3 eggs?
28 cents.
That's not a lot.
There's your X. Try this one. Find your label over label. First, you have to figure out what we're comparing. You label over label. And you guys, why I make you do that is so that you can it can help direct traffic. So if cost is on top, you keep the 2 numbers on top, the same label. Okay? So whatever label is on the bottom, those 2 items on the bottom, the 2 numbers describing those 2 places on the bottom with our proportion have to have the same label. Sam, what are we comparing? What's the label?
People served in
Oh, what the heck? What do I keep doing? All right. Give me one ratio from the problem. Lauren?
10 to 3.
You guys agree that 10 people, how much flour does it take? You said 3 cups, right? You guys agree that that ratio goes together? We have our labels right. The 10 describes the people, 3 describes our flour. Okay? Sydney, what's the other one?
15 over X.
Well, the other number describes people, so isn't that like a process of elimination? You guys see how once you put the 3 numbers in, process of elimination, then you know what you're trying to find. That's what I like about proportions. They're clear cut. What's our label on our answer going to be? Huh?
Cups.
Cups of flour. It's where the X is. Where's the X on the bottom? What's the label on the bottom? Cups of flour.
We have to,
So easy. Huh?
We have to write flour, or can we just write cups?
Cups of flour.
Alright.
Yeah. All right, so we got, what do we got? 10x, right? Is equal to what?
45.
45. We divide by 10, which most of you could do that in your head, is 4.5 cups of flour. You good with that?
Yep.
Can you measure 4.5 cups? So decimal makes sense here? You know the difference size of a half a cup versus a cup? Ever bake?
Yeah.
Make some cookies?
I like cookies.
You want to do one more and then I'll let you guys practice some more homework? Is that cool?
Sure.
It take us two. How about you do the next one by yourself? All of it. What are we doing? Not cooking, but we're doing what?
Travel.
We're traveling. All right. Does that make sense? The labels on traveling.
Yeah.
You ever compare? I mean, obviously we used to do that, but now our GPSs do it for us, and our gas, our little cars that are, you know, they tell you how many.
Now you have to go.
Yeah, until you're done. You better get to the gas station. Before, you know, we had to do this on, you know, mathematically. You know, when you drove your cars, you didn't have all this technology that tells you everything. It does all the work for you. Well, it used to. I mean, you just be an odometer, and you didn't know GPS. You had a gas tank, but like that little, this far away from E versus this far, you didn't know exactly how many gallons you had left. I mean, it was approximate. You just had to guess and say, well.
When we were driving to Florida, my dad would only done like 7 miles left in the gap in the tank, because we didn't want to stop at like Birmingham, like it was really crazy in Alabama. So like my dad kept on driving and we had 27 miles left, and like we ended up making it to like another exit, and like it's like the exit said like there was gas like right off. So like you know you go to like Sam's, sometimes Sam's places have like the gas things there. Well, we didn't have a Sam's card, and we didn't know they needed a Sam's card to get gas there.
Oops.
So we had to drive all the way down the road, and like by the time we made it, we had like 4 miles left in the tank.
Happens. Remember, there's always a trick. Well, I mean, my older car, I had to use it one time when I ran out of gas. I only ran out of gas one time.
What do you do?
You take the gas cap, open up your gas, you know, where you put the gas in, you know, you pump the gas. You take it, you open it up, you leave it open. You take the cap off, if there's a cap. You let it either dangle or take it into your car, and a lot of times what happens is you at least get 2 miles more out of your gas tank. At least the older cars could do that. I don't know about these newer cars, because right now, like my Charger actually has a, you know, like a silver thing that if I push it in, and then it seals it back up. So I couldn't do that with my car. There are some cars where if you have the cap and you can take it all the way off, and basically it just siphons the gas that's left in the, you know, like all the way to the bottom can go right back through. Sometimes you don't want to do that because your sediment that sets near the bottom of your gas tank too. So, yeah, I had to go back and get my car tuned up after I did that because there was a bunch of crap at the bottom of my tank, I guess. All right, so we got what? We got miles per. Why does it keep doing that? I don't know. We'll just see. All right, so we got. You get 483 miles for how many gallons? 14, that's our first rate. Good. And then we have, what's the other one? Oh. Where does that one go? Top or bottom? Top. Because your miles is on top. Yeah, don't worry about it. So what if, what if you decided to put gallons on top and miles on the bottom? Would it matter?
No.
Nope. As long as your 483 and 600 were also on the bottom with your miles label, you're still going to get the same answer. Your cross products are going to end up being the same. Does that make sense? So it makes you feel a little bit better. Like if you didn't write this, the label, however you label your label over label, however, what order you put those in, just make sure the numbers are in that same order on the top and bottom. It doesn't matter. As long as This is on the top, this is on the bottom, the same on the numbers described to labels. So we got what? 483. I had to call DC this morning, so she's probably my peeps out in DC.
Happened?
No, it's something didn't come, the attachment on the email didn't show up, so I need to, she was supposed to call me back, so that's probably her. All right, so we got 6 times 14 is what? We got 484?
Yeah.
All right, so now we're going to divide this 483. Now, this is where, see all this work here? Can we do this one in our heads very easily?
Yes.
Okay, this is what I'm going to tell you. As long as you have this work, you get to a problem like this, I don't mind if you if you want to do it by hand, do your long division, that's fine. But if you also want to check your work with the calculator, that's fine up to this point. Does that make sense?
So we have to do the
But
work.
you have to show the work. You cannot just write the answer.
Darns.
You understand?
I like not
So like we have to show.
Well, then guess what? If you're just going to show the answer, I'm going to tell you you can't use calculators.
Okay.
Wait, so you have to write out the long division, but we can check.
No, you don't have to write out the long. As long as you have, see this, I'm just showing you. I stopped right here. Do you see all this work here?
Yeah.
As long as you have all of this, you can do this right here on your calculator.
Okay.
Does that make sense? But as long as you're up to, I mean, you get this all done, and then you're like, if you can do it, try to do it with your mind. But if it's a big number, I don't want this to take you forever. You know what I mean? I don't want this process to be long. It should be quick. Okay? Proportions are supposed to make things easier. All right? All right, so what do we get for x?
I'm still figuring it out.
17.4.
Is it 17.4?
No, it's actually 17.
You know what, I'm doing this. I'm figuring
It said, well, does it say, let's do the whole gallons. Round to the nearest gallon.
17. No, that's
17?
Yeah.
Okay. So if you have to round, because you guys agree that this is not doesn't come out, you guys know what the approximate is? Because it's not equal to 17, is it?
No.
So watch, you guys ready?
Isn't it like the squiggly lines?
Yep, that's approximate 17 gallons. Then I know,
Oh, we can do that?
yes, you
Yes.
should. If you round, you should be doing this.
But it counts in
A little squiggly.
So,
If you round, you need to do the woo. It's like the Wayne's World, but
we have to do it
horizontal. Okay?
Wait, we have to do every problem. I found that. That's all.
What are you talking about? You guys are nuts.
It's our homework.
All right, here's your homework. Put an X on the study guide side. I don't think we need to do any of those.
It's a big packet of homework.
You're not doing it all, you nut.
Put an X on the what side? The first page?
Yep. On the 4-5 skills practice, I'm just going to have you practice finding if they're equal or not equal. Remember, I want you to just do
We have to show work on that.
1 through 12. I want you to do 2, 4, 6, 8.
2, 4, 3.
Just 4 of them. That's good. That's good enough for me. Okay? On the bottom, solving this basic proportions. I want you to try, let's do 14, 16, 18, and 20. Just 4 of those. So there's this basic, and then I want you to go to the back side, not the practice, go to the word problem side, and do the first 4 word problems. So we're just dabbling. We're doing 4, 4, 4. We're just doing a little bit of every section. We'll check back tomorrow, see how you feel. If I feel like we can move on, we'll move on. If we don't, we'll do some more practice. There is a couple problems on here that we're going to do in groups tomorrow that you're going to have your thinking caps on, but we're going to do that. I'd rather you guys do that in class. I want to see you struggle in here versus at home, okay? So I can obviously help you. All right, is that cool? 12 total, right? 12 problems? 4, 4, and 4. Remember, word problems, you have to have that work. Label over label, proportion, and your cross product set equal, and then you solve for x. Okay? Harrison, if you round, what should you have? Squiggly. Yeah, if you round, if they ask you to round. Great day, guys. Thanks for showing up.
I didn't feel like it.
You didn't feel like you showed up today?